Hello, good morning. It is another day. I'm very tired, and I just wanted to talk about something that I could just ramble about. Just like pure, unadulterated, like, here's my unnecessary opinions on a topic that I really want to discuss. And so, something that I've been wanting to discuss for a while is like the more tech facing side of aviation and automation, and kind of just like a look at the accidents that have happened, kind of like the implications that they might have on our future, and so on. So, this one is going to be a long one. I have 70 slides prepared. I have two different cups of coffee. I have my cat sleeping in the background, just very chilled out. And so, this is going to be interesting. Okay, so first and foremost, I just wanted to say we're gonna discuss a lot of like fatal aviation accidents. There's gonna be plane crash gifs and photos. There's gonna be also discussions of like mass murders and suicides that were done with airplanes. So I would just advise that like if you're squeamish about death or if you're squeamish about plane accidents, like don't go into this video. So that is my mandatory disclaimer. My second disclaimer is I know I usually put memes in the PowerPoint to make it more engaging. Because we're going to be talking about accidents that kill people, I don't want to put memes in here. I feel like that's just not really respectful. And I would rather keep the focus on the subject matter. I also did want to say I am just a programmer. I don't know anything. I've never flown a plane. I've been in a plane. I enjoy planes, but I'm just rambling and I'm not an expert. And I would just advise that you do your own research and come to your own conclusions. But these are the conclusions that I have come to from my research, which is just being on Twitter and all that jazz. So, what we're going to discuss today is aviation crashes, automation, how automation can work against us, some potential fixes and some implications that we've seen. Also, like what implications kind of like the aviation's industry struggle with automation has on self-driving cars, and then also questions about like the limits of automation and like how much we should really be allowing it to do. So this was me a couple of days ago. I love the Sky Terrace at at SFO. I was just hanging out there, having a good time, and I saw the world's largest commercial jet. I think it's the Airbus A380. I could be wrong. Please don't shoot me. But I was looking at that and I was just like thinking about a lot of tech stuff, and it kind of inspired me to come up with this video about like, okay, like I know a while back, like especially a couple years ago, there was this giant discussion of automation in the aviation industry, especially when looking at the 737 MAX incidents. And I feel like that conversation is kind of quieted down, but I still feel like it's an issue. And I still feel like we're just not talking about it because there hasn't been recent accidents, but that doesn't mean that the problem is solved. So I wanted to discuss a accident that I find particularly intriguing, which is Air France 447. Basically the gist of it, and so I'm gonna go into the high level and then I'm gonna use a article from a really respected aviation writer that kind of goes into more of the background. But the high level is like a bunch of tired crew got on a very highly automated plane. It had autopilot. It also had like safe flight envelopes. So basically, like if you were flying this plane when like these flight envelopes were enabled, you literally could not crash the plane. Like the computer would not let you, right? And so a normal weather event happened that blocked one of the tubes that does airspeed readings. And so autopilot just randomly shut off. And the pilots were like, oh my God, now we have to fly this plane. And they were pretty much just like flying in the middle of the ocean. They weren't doing like takeoff or landing. But this was basically a plane where you could really set it and forget it. And you were more so there to babysit the plane and not necessarily fly the plane. And so they have an instrument kind of issue. The autopilot shuts off. These people are tired as shit. They're in the middle of the ocean. And they pitch the aircraft pretty much really high. And that leads to it stalling. So when you're flying a plane, you need to go forward and you need to have an angle of attack. That means you kind of get a little bit of lift. And so if you have too high of an angle of attack, you can't move forward. Boom. And that's what kind of happened at Air France. So they basically stalled the plane at a very high altitude in a way that the plane normally wouldn't allow them to do. And then they didn't realize seconds, and they basically didn't realize until like 5 or 6 seconds before the plane like fully crashed. So this is Admiral Cloudbird. It's a really cool person. That's what I'll say. Because I can't say the name for some reason today. But this is Admiral Cloudberg. She, I believe it's a she, is an aviation writer who writes these really amazing in-depth reports about all of these different aviation accidents, and she inspired a lot of the stuff that we're going to be talking about today. So I would recommend you go check her out on Medium, and I know she also has a Patreon. So this kind of basically is just more the in-depth version of what I already said. So basically, the pilots were super tired, but they were also like, this is an A330, it's a pretty advanced plane. You'll notice here that it says incorporating flight envelope protections that would make it impossible for the pilots to pitch up too steeply or down, fly too fast or too slow, or do all of these other things, and basically that they babysat the plane. And this is a phenomenon called St. Elmo's fire. This also happened on the Air France flight. It's a pretty common occurrence. I forget exactly what happens, but I think it has something to do with cold weather and electricity. And so what ended up happening was there is a pitot, I can't pronounce stuff today. So just, there was a tube, and they were basically flying through this kind of like icy cold patch of the sky. The tube, which basically measures the airspeed, got clogged with ice, and the autopilot disconnected, and then auto thrust shut off. And so the first officer was like, oh my god, oh shit, like here we go, like we have to fly this plane now. And so this is something that I thought was super interesting, where it's basically like Airbus has flight control laws, which is basically like, if this is happening, then this can't happen. And so basically what this is saying is like, when sensor failures occur, like what happened with the pilot tube, the controls drop down a level, and there's like different levels, and each of those levels can change the flight envelope, which is basically what the plane is allowed to do, how up or how down it's allowed to go, how fast it's allowed to go. So basically what this is saying is like, because the sensor failure occurred, it entered into like a alternate mode of like autopilot, and it shut off a bunch of stuff, and it's very hard to just know like the state of everything with autopilot, because there's so many different like sub modes, and there's so many different like instruments and things that are affected by it. So it's basically pointing out like, it's just very hard to understand what's going on there sometimes. So this is a section more about the first officer on the plane, who was the one who grabbed charge of the controls. I think one of the captains was asleep, and it was two new crew members, or not new crew members, but two other crew members who were just flying the plane during a storm through the night. And so something that was really interesting is it's talking about how his training was all on these very heavily automated plane, and there wasn't a lot of focus on the traditional skills of flying an aircraft. So basically the gist of it is like, instead he spent the next 2,000 hours watching as computers flew the jet on his behalf. His total time actually hand flying an airliner couldn't have been more than a couple of dozen hours, all of them within the bounds of flight envelope protections. So his only experience was like a couple of dozen hours flying a plane that literally would not let him crash, right? So it kind of babied him. And this is also making the point that like, most of the time Airbus aircraft literally just cannot stall because of those envelope flight protections, even if the pilot is like and just like shaking everything, right? So it's really interesting and also hard to digest accident, because I think this section of the article really points it out, is like, yes, on some level, like the first officer was responsible and the crew was responsible for like trusting in a highly automated plane, but also it brings into thought like the question of like, is automated airplanes actually systemically undermining pilots going through training? Like, are we making worse pilots because we're making their jobs easier? Are we making worse pilots because we're literally not allowing them to crash? Like, are we making these planes so safe that they actually come at a cost of some amount of safety, right? So this was also a really interesting point. As long as humans fly airplanes, some amount of information will always be lost while translating between man and machine, and from these imperfections spring the seeds of catastrophe. The next major crash of a large airliner, wherever it may occur, will almost certainly have something to do with the interaction between pilots and the automation they oversee. And I think this is a really interesting point because we're kind of having this like public debate, I guess, about self-driving cars and the question of like, okay, well, even if self-driving cars do crash, is it more or less dangerous than having people who otherwise would crash anyways on the road? Like, is there kind of like a counterbalance in between, yes, we know these things are going to cause accidents, but also like with no computer intervention, there would be this much more accidents, right? So when is kind of like the limits? And so this GIF kind of like basically shows how Air France hit the ocean. It's pretty hard to watch. But that's kind of what I mean by like, it was stalling so much and it was pitching up so much and they didn't even realize that they could really go that high, and they had the wrong airspeed indicators. So they thought they were slowing down when they were actually going pretty fast at a pretty high altitude until they stalled and completely hit the ocean. So there's a couple of other specific accidents that I want to touch on a little bit. I'm not going to go too in depth on them, but I'm just going to give like the high level summary. This is the flight that I was thinking about when I was sitting at the Sky Terrace at SFO. Like I was looking at the seawall, I was thinking about that plane, and I was reading the Admiral Cloudberg article about it, and I just thought it was so interesting. So basically what happened was, I believe some sort of landing instrumentation system was down at SFO. And so this pilot who was kind of new on this plane was flying in, and he was having to do basically a manual landing. Planes can be landed through ILS systems or through other systems that basically do all of the work of landing it for them. So this is an interesting point that the plane was landing, it was being flown by, I believe, a new pilot to this specific kind of aircraft, and he had an instructor right next to him. And I don't know if you guys have ever been to SFO, but there's basically a seawall and then there's a runway, and you're pretty much like flying in directly over the bay. So there's a really, you really don't want to land in that. So what happened was the Airbus actually clipped the seawall, and then it fell, and then it spun around and flung people from the plane. And it was pretty bad. I think 3 teenage girls died, and it destroyed a perfectly good airplane. So one of the things that this says was that the auto throttle was like armed, and the pilot kind of didn't necessarily understand how much the plane was doing automatically and how much he was doing manually, right? Like he thought he had more protections than he actually did, similar to Air France, and it resulted in this. And so I'm not going to show the video on here. If you want, you can look it up. There's like security footage about it, but it was, yeah, there was a lot of G-force being added to that plane. Admiral Cloudberg put this photo in her article, so this is from there. I would recommend you go read about that specific crash here. And then this one is probably the most devious out of all of them. And I don't necessarily think that the lack of autopilot would have changed the situation, but I think it brings into play a very interesting question of like, should we be allowed to tell computers to do stuff that will kill us? And so basically an Airbus A320, which is a very common, very safe plane, was flying, stopped responding to air traffic control, and crashed into a mountainside, killing a lot of people on board. And so when they recovered the black box, they actually heard that, I believe the first officer locked the captain out, and then he set the autopilot to descend to 100 feet, and then it crashed into a mountain and killed everybody. So it was a mass murder / mass suicide, and it was obliterated. And of course, we can't talk about automation and about software and aviation without talking a little bit about the 737 MAX MCAS system. So I'm pretty sure you guys already know what this is, so I'm not going to go into a lot of detail about it, but basically there was a piece of software that was installed supposedly because of a change in the 737 MAX engines to correct the plane so that they wouldn't have to have pilots go through retraining. So basically this entire like software mechanism was basically built to save money, and it wasn't tested super well. Allegedly, Boeing, please don't sue me. And it allegedly, actually no, I think they did settle. It killed a bunch of people. It killed two different planes, one of them an Ethiopian Airlines flight, one of them a Lion Air flight. I believe all of the passengers and crew on both of them died. Here's an image, I believe, of the Ethiopian airline flight. And two of the important points that I want to make is like the software wasn't tested well and it wasn't disclosed, I don't think, to the pilots at all. And also that people who buy software want to trust it and they want to believe that the due diligence have been done. And I think we give a lot of software developers in general just a lot of like credit and freedom, and a lot of times software can build these amazing and complex pieces of infrastructure on our modern internet and just in our modern world. But as the PowerPoint says, sometimes not even the doest of dillies has been done. And I think this was kind of a good example of how they were just like, testing? We should test this? Okay, that's a little crazy. Like, and it's also a good example of like how even like the smallest of incidents or like the smallest of things like on a large scale can really have a lot of problems, right? Like if you're developing software and it has a bug that's like 1 in a million, maybe if you're only anticipating like 50 people will use the web app, then you don't necessarily need to fix it. But if like 10 million people are coming to your web app, that's a very it's a relatively high number of people who are getting fucked, you know? So now we're discussing how automation can work against us and like the specific things that I wanted to bring into question. So there was also another incident where someone or a pilot put in the wrong data into the autopilot system and it crashed. I also wanted to tie it back to GermanwingsFlight and say like, should the autopilot have even accepted 100 feet into a mountain as like data entry, right? Like if it could project where the location would be, like, is that okay for a computer to do? Is it not okay for a computer to do because it babies pilots? And then I wanted to talk a little bit about like the additional layers of automation and how it kind of like interacts in the cockpit, right? So pilots have a lot of stuff to keep track of. Planes are very complex machines. They have like millions of moving mechanical parts. If you've ever been in a cockpit or if you've ever looked at a photo of a cockpit, there is so many switches. It is a lot of information overload. And I think it's important to note that autopilot does abstract a lot of that away from pilots, but it also adds something that they have to think of, right? Now it's like, okay, now I need to know what this, and this does, and now I need to know like all of these different modes of autopilot and then all of these different like failure modes of autopilot and how they'll change the flight envelope protections. And I don't think that's asking necessarily like too much from pilots, but I do think we should be like, is that a smart design choice if they already have so much to keep track of, you know? And then I wanted to also point out that like the addition of additional complexity makes it harder to debug in emergencies. Like there's already so many accidents that have happened in the aviation industry where it was like a completely unrelated issue that went wrong and the crew spent so much brain power trying to figure it out that they actually like crashed due to other reasons. So I don't remember the exact names, but there was a plane crash that happened in Portland because I believe they just didn't realize they ran out of gas. I believe one of the Everglades plane crashes happened because this was like relatively early in the days of warning system, and one of their light bulbs on one of their switches, I believe, went out, or on one of their buttons went out. And they were like, well, we can't tell if the landing gear is up or down because this light bulb doesn't work. And it's like all this whole thing, like, is this landing gear down? And then while they were trying to figure that out, they crashed, maybe because they ran out of fuel. I don't remember the exact reason. But long story short, there's already so many accidents that illustrate that crew resource management and like keeping your head above water is very hard to do in emergencies. And then something else that I really want to give the people who died in these accidents credit for is like automation is really consistent and it's designed to be really smooth and it's designed to make your life easier. And when something does that like over and over and over again, you trust it. And so when autopilot is like doing stuff that it shouldn't, or when it like kind of like disappears, or when it gives false readings, that's like hard to deal with. And it's also even harder for pilots to understand like where the source of failure is, because it might be an issue with the autopilot, but they're like, oh well, autopilot's been so trusty in the past, how can it fail now, right? And also the misunderstanding or losing automation obviously can lead to horrible outcomes, like as we've seen pretty much with almost every accident in this PowerPoint. And so I wanted to go over quotes from a couple of different articles, just kind of like reiterating more of the points that I already discussed. This is a really interesting article that says like pilots can't wait for planes to be better designed and they need to have more training to understand how to interact with autopilot. And then also it's hard to understand like the state of automation and what is in your control versus what is in the computer's control. So maybe this is a design issue, maybe this is just like a human computer interface issue. I don't necessarily know, but I think this is a really good point made by this article. And then I also wanted to talk about automation as a false god, because I think it's something that we as a society are starting to continue to jump into, where we're like, oh, like if this has been automated, then it's kind of better, right? And so one of the interesting points that I really just want to hone in here on is like automation keeps us safe from previously known dangers, but if we're not looking, it's going to create new ones that we're not aware of. Automation also creates a blind sense of security and it leaves us blind and vulnerable. Like the thing that I'm thinking about right now is that Uber accident where a pedestrian was crossing in Arizona and Uber didn't even recognize that, or maybe it did recognize that something was moving in front of it, but it didn't recognize it was a pedestrian and it just hit the person crossing head on and killed them. So that's kind of like an instance of what I mean by it keeps us safe from previously known dangers, but creates new ones, and it leaves us like blind and vulnerable, right? Like that pedestrian probably was like, oh, this car is gonna see me, and the person in the car was probably like, oh, like the car is gonna know that there's a pedestrian coming up, right? And I think it's important to note that like a lot of times when we know that autopilot is failing is like right in the moments right before an accident, right? So it's like when that Uber car was choo-chooing towards the passenger. I'm sorry, I don't mean to be disrespectful, but when that Uber car was coming for the pedestrian, the driver was probably like, okay, like maybe the car will stop. But it's only until like the last second when you realize, oh, this is not doing its job, that you need to jump in. But usually in those moments, that's like when it's too late and you're already past the point of no return. So going back to the Asiana Airlines flight, the instructor did know like right before they were about to hit the seawall that they needed to go up and they needed to go higher, and they were trying to fix the mistake. And so did Air France, right? And both of the pilots, or I think most of the people involved with the 737 MAX incident, were trying to shift the plane up so that it wouldn't immediately nosedive and crash and kill everybody. So it's not like these things like, it's not like people, okay, you know what, I'm gonna end that thought, but I'm gonna keep it there. And so one of the interesting things about automation is it has so many details and it hides a lot of directives underneath a user-friendly layer. And if you've ever worked in programming, you'll probably know what this means intuitively, where it's basically like, let's say on startup of an app or on startup of a piece of software, I need to check user credentials, I need to change font color, I need to send something to a database, I need to pull something from a database, and I have like all of these subtasks. So usually what I would do is I would like write those 5 in a logic controller, and then in the actual view controller, I would just write a function that says startup like landing page. And so then the view component would talk to the logic component, and I don't see that logic, right? Because it's pretty much like single responsibility. I'm abstracting that logic away so that it's not in code where it doesn't need to be, and I don't necessarily need to think about it. And so one of the interesting points is like when that comes into real human-computer interaction, that abstraction can cause you to lose sight of the failures underneath, right? So in hindsight, or like if I use that code base and I think about like, okay, like I need to modify like this function, I'm not going to think of all of those little sub steps. I'm just going to think of the function like startup landing page, something, something, right? And I think a really human example of this that probably everybody can relate to is like when you turn on airplane mode and then you try to load an app and you're like, why is this not loading? And then you're like, oh, because I put airplane mode on, right? Like I feel like it's very human to forget like that you set modes and that it changes stuff and how things work. So give me a second. I'm going to make a coffee break. Okay, let's go. I thought this was really interesting. Mode selection errors were cited in 27% of the accidents reviewed in an FAA study. This just talks a little bit about like one of the issues that's showing up in automation related problems is just that like pilots don't pay attention. They have the airplane mode issue, right? They're like, oh, I didn't realize this autopilot was in like X mode and not Y mode, right? So they're kind of like forgetting the limitations or who is really owning what. And then I also did want to point out, like, this is something that I, as a designer and like as a programmer, think about a lot is like humans fuck stuff up. And technology is confusing, and not everybody has the same background, and not everybody understands what it is. And so, whenever you're designing a piece of software, you always want to make it as user friendly and as understandable pretty much as possible. And even if you've done your doest of dillies, people will still reach out to you and be like, hey, like this is an issue. Or like, hey, I didn't really understand this. Like, I had this person reach out to me after they had downloaded one of my apps and they said, hi, I clicked download. And then I was like reading through and I didn't see if it had charged me. And if it had charged me, like, please give me a refund. And I responded like, hey, the app was free. It said that on the App Store description. And if you do encounter a problem like this, please reach out to the App Store team in the future because I, as a solo app developer, am not able to control the App Store, contrary to popular belief. So that's kind of an example of like Apple has put probably so much time and so much development into making the App Store pretty much like the most accessible and the most understandable for a wide general audience as much as it could be, and people still get confused, right? So I want us to also think about the fact that like humans cannot be technology and humans aren't technology, and there's always going to be a degree of variability, and technology itself is never going to be perfect because it's programmed by humans, and because even if it's being like programmed by AI, it has bias, and it doesn't necessarily like, just because something is automated doesn't necessarily mean that it's being removed from the human stain that pretty much goes into any tech project or into any human decision making. So let's talk about what we can do about it, right? One of the interesting things that I was thinking about, like, with Air France is, like, there is no gradual failure of automation. There's just immediate shutoff. And that can kind of lead to this, like, jumping in cold water effect where you're like, oh, fuck, like, I'm jumping in, I'm freaking out, I'm trying to get control of my whereabouts. And I think that's something that's also kind of on my mind because I read a Tesla article and allegedly, winky face, allegedly, Tesla was thought to have programmed their vehicles like in autopilot to turn off seconds before a crash, right? And so that, and then Air France, and then all these other things makes me kind of like think about like, would it be better if there was like a sloped period in which like it was like, hey, autopilot is going to turn off in 5, 4, 3, 2, 1, right? Like, is that better design? Is it worse design? Would that be able to give people like a little bit more of a heads up on, oh shit, like I have to get ready and I have to get engaged? And then also, here's what I'm thinking about. Like, should we be allowed to tell machines to do things that are not in our best interests? Like, GermanwingsFlight literally mass murdered people by setting the autopilot to 100 feet. And I don't think it would be an insane stretch of the imagination to sit down and think like, okay, like autopilot could have terrain models like in the code, and they could basically check the mapping of the flight path and see if it's going to lead to a crash. Like, should it be allowed to do that? But also conversely, should it not be allowed to do that? Because in Air France, they had those flight envelope protections pretty much like all the time. And those protections actually worsened the situation because they underprepared the crew to deal with an actual real emergency, right? And then I also wanted to think about, like, is there cues that we can take from hardware testing and or more of the stuff that's coming out of DevOps? So I've been thinking about DevOps a lot. For people who don't, for people who aren't like in the software industry, DevOps is like a very specific, it's a very specific type of person, and they basically are responsible for making sure that like all of the infrastructure that goes into software is up and it's running, right? So DevOps really focuses on like server uptime, fixing server issues, like all of these other things, predicting failures, predicting where stuff could go wrong. It's kind of like cybersecurity slash hardware slash software slash like problem solving slash like forensic investigating. So it's pretty interesting. And one of the, I guess I would say newer because it hasn't been around that long. One of the newer things that's come out of DevOps is the idea of chaos engineering. And I think Netflix's engineering team was the first to come up with this, and they wrote a technical paper about it. But basically, chaos engineering is where they fuck up like one piece of the backend and they just see what it does, right? So they see if it creates cascading failures, which is like, let's say you have one DevOps component that's linked to another, and if that DevOps component fails, this component also fails, then this component fails, and then the whole system is down because like domino effect, right? I also wanted to say that software works by doing small scale beta tests, and it's like a very small amount of people, and then there's like an alpha, so there's more people, and then there's like slower rollouts, right? So maybe it's the case where and also I wanted to say I don't know shit about aviation software, and I don't know if people are actually already doing this. I don't know if I'm just like resuggesting stuff that's already been implemented within these software engineering teams, but if I were to make guesses on what we could think about without having any of that background, which is the point of this channel, is like I just want to flex my hubris. I want to just do thought exercises even if they're completely wrong. Like I would say potentially doing smaller scale like automation rollouts of autopilot changes, so that maybe like at first it's only 10 planes or it's only 20 planes, and then it kind of like rolls out a little bit more. I do think Tesla self-driving beta already does this though, where they do slowly roll out. I don't know how it is with planes. Maybe that's not how it works. I don't know. I also think there's interesting implications of chaos engineering on software flight systems. Like, I don't know how software flight systems are already tested. I think that would be an interesting tool to implement against automation if we already have it, where it's like, hey, like if you give the automation this unexpected input that it never thought it could do, like here's how it would fail and here's how it would fuck up. And I think actually it would be really interesting to have that chaos engineering like in the context of flight simulators for pilots, where you just have it all set up and then pilots have to cycle through a couple of like chaos engineering cycles where like random little components get fed the wrong data or something gets fucked up, and then they have to like recognize the autopilot is failing, they have to come in, they have to fix it, and they have to figure it out and move forward from there, right? Because like that's pretty much what happens in flights, is like random stuff fails, random stuff happens. And so I think that would potentially be a better way of preparing pilots for failures of automation and for teaching them like, hey, like you are babysitting this stuff, but if the time comes when it's fucking up, like here's how you know what to do, right? And then also maybe just like software simulations. I'm thinking of accelerated hardware testing, which is basically like where components are put through as much stress as they can possibly undergo, so that way the manufacturer can understand, okay, this is like these are like the limits of like the software and what it can and what it can't do. And so I think like if we combined that kind of like accelerated testing idea with the chaos engineering idea, and we just figured out like what areas of automation fail with specific inputs, I feel like that would be a really good way for us to start understanding where like the unexpected pain points of automation can be. And like if there are like data entry things, or if there are like instrument kind of things, like there's a something and something chance that this will fuck up, and kind of treat it more like hardware, where it's like, okay, we know that at some point there is a failure point, but where is that? Can we even find that? How would we even like get that going? So that's kind of my idea. Is like I think it would be interesting if we could treat software as more of like a hardware thing. Um, Here's my general, these are my general idea of fixes. Some of these have already been implemented. I didn't come up with all of them, but I just thought it was pretty interesting. So maybe a gradual period of turning off automation so there's not that cold water effect. Boeing, Airbus, if you implement this, I am expecting a royalty check. If you don't implement it, that's okay too. If you implement it and it causes crashes, I'm deleting this video. So I think that there's also this push to reduce the total amount of using automation and to keep pilots basically using their flying skills as much as they can in safe situations. So that way, there's not this kind of effect where you're just like flying stuff and then you're babysitting stuff. It's more like a combination of two. And then also, I feel like there should be better design indicators about modes and what is happening as a result. And I think if pilots don't know that, it's because it's so much information to have, and then maybe it's a GUI error, maybe it's like a UX error, maybe it's just like something where cockpit engineers kind of gotta like put their noodles on it and be like, okay, we should show this and then the relation to these things. Because I think because hardware is so unseen, it makes it so much harder to know where it actively stands. So I would like to potentially see maybe some like UX ideas about this, right? And then also maybe like increased validation steps for input, right? So maybe like, are you sure you want to crash this plane into a mountain bestie? Like, are you sure you want to go to this location? Just like opt in, double confirm, right? Yeah, I don't necessarily know if that's already in place or if that would be doing anything, but that might be helpful for data entry stuff, or like maybe like the first officer puts it in and then like the pilot reviews it, so it like goes through like a two-step verification process. Also potentially more data and more kind of like error simulating within autopilot for it to refuse to do fatal stuff. So this was my kind of idea when discussing the Germanwings thing. Like, should the autopilot have been allowed to basically be like, it's time to crash into a mountain? Like, the autopilot still turned off and it was still like, terrain, pull up, but it was still instructed to do it in the first place. Like, should it have been? I don't know. It's a good question. And then also potentially like better testing pipelines for software. I mentioned some of my ideas about implementing chaos engineering within autopilot and then also implementing accelerated hardware testing. So it's just like a bunch of rounds of chaos engineering on all of these different components, like maybe thousands or even hundreds of thousands of times. But they might be doing that because that's expensive as shit, and computing is expensive, and they just don't have enough AWS credits. I don't know. But like that would be how I would imagine the testing pipeline. And then let me propose. I believe, in my opinion, that there should be a third-party software safety review board for autonomous transportation systems outside of the Department of Transportation and outside of the FAA. Who should verify the safety of software? Let me take a coffee break and then we will discuss. Okay, here we go. Should there be a third-party authority responsible for verifying automated software safety, like with the NHTSA and the IIHS crash test? And so if you don't know what those are, they're basically where the safety rating on your car comes from. So like a Mitsubishi Mirage, I think, has like the worst rating, and then I think like SUVs have the highest rating just because of the size differentials. But here's my point. I do not trust airplane manufacturers. I do not trust airlines. Sometimes even the FAA is on thin ice. National Transportation Safety Board, I love you. You have changed so much and you could never do anything wrong ever. But my point is airplane manufacturers and airlines care about shareholders more than they care about safety. And we've seen it, especially with Boeing. Oh my gosh, I just don't trust them. And so now we're going to talk about some accidents that have happened that illustrate why I do not trust them. So let's talk about what I consider to be the most influential aviation accident to me, which is Alaska Airlines 261. Basically what happened was it was a flight and their horizontal stabilizer broke. So the horizontal stabilizer is this thing at the back of the plane. It basically is like, I don't know if I'm describing it well. So sorry, aviation enthusiasts. I'm just here to have a good time. But basically, there was this jack screw that controlled the horizontal stabilizer, and Alaska Airlines did not properly grease that jack screw. And after so many uses, it just broke. And then the horizontal stabilizer was being held up by something that wasn't rated to hold it up. And then that broke too. And then they couldn't control the plane. And they flew it. The pilots were trying so hard to save the people on the airplane. These people were scared shitless. And they flew upside down into the Pacific Ocean and they died. And it's horrible. It's so sad. But I think the last words of the pilot, literally, like, the plane went upside down. Like, the last words of the pilot were, "Here we go," like, as they're about to hit the ocean. And I would like to have that level of acceptance. Or I don't know if that was acceptance because I've never heard it, but I just think those are, like, insane last words to have. Okay, I digress. But Alaska Airlines corporate greed made it so they cut maintenance efforts, they reduced the workforce, they lengthened the time between checks on the plane, and they also, like, weren't necessarily doing a lot of QA on the stuff that they were completing, right? So if, like, a maintenance worker came in and they greased the jack screw but they didn't do it correctly, nobody was, like, verifying that it was done correctly, basically. So that's kind of my point. And I think there's many other examples of, like, airlines will do literally anything they can to turn a profit, and sometimes that involves cutting down maintenance. And there have been many incidents of many budget airlines specifically just, like, foregoing or not doing maintenance, and then sisters, right? So I now want to talk about United Airlines 811 because I have issues. I have a vendetta. So long story short, 747 is a beautiful, iconic plane. Basically, there was an issue with the cargo door that kept on, like, popping up I think in the 1980s, 1990s. And Boeing was like, "You guys just don't know how to close this door, and I'm so sorry that you guys are so dumb." And so basically, like, they were looking at the latches and they were like, okay, there's actually an issue here. Like, these cargo doors are just, like, pushing open because it wasn't like they were coming in from the inside and they were, like, nozzled up against something and therefore they couldn't, like, it wasn't that they opened on the inside, right? Because if they did and then they closed against the frame, it would have offered more protection. But it was more like they opened from the outside and then they closed in. And when you're thinking about pressure and when you're thinking about the constant pressure stress on planes, that difference is, like, pretty important, right? So it's kind of the difference about, like, if I popped this coffee lid up versus, like, if I flipped it upside down and I tried to pressure it. Like, we pretty much know that this is gonna hold, while me just, like, popping this off and putting pressure on it is not gonna hold that well, right? So long story short, they were basically like, okay, we admit this cargo door is a little bit fucked. Like, we're gonna give a low grade service bulletin or something, to, like, reinforce the door with steel. But they were like, it's okay, besties. Like, we have a year to do it. It's all good. And then the cargo door on United Airlines 811 basically exploded off the plane over Hawaii and sucked out, I think, 9 people. And then Boeing does what Boeing does, and they basically were like, this isn't our fault. Like, one of the victims' parents got involved, and he was an engineer, and they basically went on this whole, like, journey to get Boeing to admit they had liability for this issue and that it was actually an engineering issue. And then this is just discussing that, like, Boeing's lawyers just do not give a shit. They are so unempathetic. They only care about protecting the company, which, like, that's how companies work. So, like, surprise, surprise. But, like, these people got sucked out of planes, and then they were basically, like, talking shit about the victims' families and, like, the victims to the jury so that they wouldn't give them money. So there's that. This is also a mention of, I believe, the Campbell family, who had a son who died on the flight, or who was sucked out of the flight, and the dad was a retired engineer, and he was basically like, this cargo door like isn't working, and then they went through the whole process of bringing it to Boeing's attention and trying to get it fixed, and Boeing really did not play nice with them. So, long story short, Boeing has a history of allegedly being a little bitch, and I don't trust them when it comes to automation, and I don't trust them to make these autopilot uh, pieces of software safer, and I don't trust them to not do this again. Like, they haven't given me a reason to trust them. And so my sub bullet points are the 747 cargo door, the 737 rudder issue, which was kind of the same thing as the cargo door, where they had a flaw with the rudder that would create a hard stopover, which is basically like, if you're pushing all the way to the left, your plane would not go left, your plane would go right, right? So these pilots are like, left, left, and then the plane's going right, which also killed a lot of people. They also have a very well publicized history of going from this beautiful engineering culture to what I would describe, in my opinion, as being a shareholder whore when they merged with McDonnell Douglas and when they got new leadership. And I think the 747 Max incident and response, I think their history of legally bullying families, and I think their history of just like never taking any accountability until they're like forced to, is more than enough reason for me to not trust them. And then this was something that, it's not funny, but I'm laughing because I hate Boeing so much. Their lawyers argued that they shouldn't have to pay as much money to the victims' families of the people who died in the 737 MAX plane crash, because they crashed so hard they wouldn't have time to suffer before they died. Like, Boeing's lawyers legit tried this shit in court. So, long story short, do I trust the FAA, or do I trust Boeing, or do I trust Alaska Airlines or any other airlines to really do anything that's not the bare minimum about automation? No, because it requires upfront investment, and doing things upfront and not when they fail is stupid, and it's a waste of shareholder money. So, not to say that there's not going to be not to say that there's not going to be quality airlines and quality airline manufacturers who do care about this stuff, right? But we're only as strong as our weakest link when it comes to aviation accidents. And so that's why we see a lot of like low budget carriers like having crashes, and why we see a lot of like smaller like general aviation planes having crashes. Like, the aviation industry is really only as strong as its least moral character, and like an accident only on like Boeing planes is still an accident that hurts the entire aviation industry. So, do I trust them? No, I do not. And so let's discuss the implications on our future, because I feel like this has really clear parallels to self-driving cars for me. And I think we're already starting to see the issue where there's a false sense of security. There's not clear limits on giving programs illegal input that's consistent across all of these self-driving car manufacturers. There's constant trust until it's taken away and gone. And we're already seeing people having sex in Tesla and putting it on porn websites. Like, people think this shit is a joke, and they're not paying attention, and they will do stupid shit to make content. And I just don't think we should have cars in general, so I'm pretty biased. I'm a public transportation girl. But this article came out in February of 2023, and basically Tesla recalled, I think, about 360,000 vehicles because regulators said that the autopilot basically broke the law. And Tesla was like, "Oh, we don't think so, but we'll fix it anyways." So, long story short, that was a lot. That was a lot of content to think about, but I feel like we should have this discussion because the aviation industry is one of the most prominent when it comes to software and safety visibility, right? Like, if Facebook fucks something up, they probably have like a couple of months to figure it out. Like, there's not necessarily the immediate effects. Like, we literally are just starting to get studies coming out that say that Instagram is bad for people's mental health, like, after it came out, I believe in 2012, 2011. So, like, it's taking like a lead period of maybe like 2 to 10 years for us to figure out issues with consumer software. And I feel like it's more of a immediate like reverberation in the transportation industry because there's so many more usage cycles. There's so many more like varying types of input that can be given to these like cars, and they're also dealing with stuff that's way riskier, right? Like software is just like Facebook is just taking my cat photos, but like Cruise is driving me around and Tesla is driving me around and like Airbus is landing me in France, right? So the stakes are much higher, and when the automation fails, it's much more visible and it's harder to, it's just much more public because of A, how prevalent and prominent the aviation industry and the transportation industry is, and B, how severe like the consequences are. Like airplanes hold a lot of people, there's a lot of flights coming in and out, and it's very visible when they fail, even if it's like more safe than most people think it is, right? So the open questions that I have is like, who is responsible for establishing and maintaining the safety of automated systems? And I know that some of you programmers are libertarians and you're gonna hold a gun to my head and you're gonna be like, don't give us another fucking government agency. But I just don't trust. I don't trust airliners. I don't trust airplane manufacturers to be doing the right thing here. And so I would love to see a kind of like automation safety verification board of some kind. I would also love for there to be like discussions about like, is there limits on telling automated systems to do bad things? Like, should those be in place? I would also like it if maybe, and this is something that I don't necessarily know will happen, but I feel like it might also be a good call to say like all automation systems have to behave in like XYZ ways, so that as people transfer like models of self-driving cars or models of airplanes, like there's still enough consistency where your muscle memory like isn't completely fucked, right? But I feel like that would also require like software developers or software manufacturers to give up their competitive advantages. So I don't feel like that would happen, but I feel like unification of these standards and of data input and of like flight envelope protections would be helpful if possible. And then I also think there's lessons that we can learn from the DevOps industry and that we can learn from the hardware industry. And once again, I don't know about the testing of automation systems. I don't know if they're already doing these things, but this is just a brain exercise for me to take what I know off the top of my head and to just kind of like figure out what it looks like. So that was pretty rough. I don't have memes, as I have said, but I do have serotonin. And today's serotonin is this like amazing potteryist, I'm just gonna call him a pottist, who makes like the world's cutest little cat figurines. I follow them on Twitter. I love them. They just make these cats like hanging out. This is so cute. I love the cat sleeping on the mug. And as an ending, thank you guys for letting me ramble. I love rambling for an hour straight about things that I have no idea about. I love talking shit about Boeing, and I love making power planes. So this has been quite relaxing for me. And then I also wanted to say, National Transportation Safety Board, I'm ready. Put me on the field. Let's go. I have no college degree. I dropped out of high school. I only went through half of AP US World History, but I feel ready to save the aviation industry. So let's talk. And then Boeing, if I see any of your lawyers looking at me on LinkedIn, if I see any private investigators, if I get a lawsuit notice, please don't. First and foremost, I'm 21. I'm a baby. Secondarily, it would make me cry. And third, it would just prove that you're more of a trick-ass bitch than I already said you were. So, okay, I'm so scared that Boeing's gonna sue me, but then I'm also like, why would they sue me? Because I have 3 subscribers. But okay, Boeing, don't talk to me. That's the end of the story. Boeing, don't talk to me. So I hope you guys enjoyed letting me ramble about stuff that I know nothing about. And I hope this was just like enlightening and it provided some good stuff to think about, like as we continue to flesh out, what does automation look like? What are the limits? How are we interacting with it in daily life? And what are the consequences of what we don't see? So I love you guys. Thank you. Goodbye.